let's solve this problem. We'll have my number n, then we will write n numbers, and out of them we must find the numbers which are perfect squares. So 9 is a perfect square because it's a square of the 3, 15 is not a square number, 16 is a square of 4, 4 is a square of 2, 5 is not square, 1 is square of 1, 7 is not square, and 9 is square of 3. We must sort the square numbers without affecting non-square numbers. So we'll have all these numbers, and the square numbers are painted in red here. I will have two other vectors. So for the vector Vn, I'll put the square number, and for the Vp, I'll put the position of this number. So like 16 goes here, and here goes the position of 16. So 4 comes here, and here comes the position of 4, and so on. And then I must sort this array. After sorting the array, I will put number 1 at position 0 here. I will put number 4 at position 2 here. I'll put number 9 at position 3 here, and so on. So first of all, this is n, and pos is the position indicating to the element of vector Vp and Vn where we put new values. So at the beginning it's 0, then after putting values here, pos must be 1, so we must increase the value of pos. So then we read number n, and I created the vectors for v for our numbers, v pos for positions, and v square are for the square numbers. Then I create a loop where I run from 0 to n. I read the vector at position I, and I say that x is equal to the square root of vi. Why did I do it? So for example, what is the square root of 4? It is 2. If I multiply 2 by itself again, I will get 4. And pay attention that x is integer, which means it will have only the whole part of the number. So let's say we have number 7, and the square root of 7 will be 2.54. But as an integer, if I have only 2, and I multiply it by 2 again, I will get 4, which is not 7. That's why, after getting square root of y and assigning it to x, I must check if x multiplied by x is vi. If it is, I'll put to the v pos at position pos I, the position of the number, and to the v square at position pos, I will put the number itself, and I will increase pos. Then after doing it, I will sort my vector v square, and pay attention that we have only pos elements inside of vector square, so it's our last element. And then, but to use the sort, we must include the algorithm, and to use the square root, I must include cmath. And after sorting my numbers, starting from 0 until pos, I will put to the vector v at position v pos I my numbers at v square. The operation which I do here is performed here. And after doing it, I will print all the elements of my vector v from 0 to n. Let's add our solution, and that's it.